Oh, hi, colleagues of the ManglarX team. This is Fernando Miralles-Wilhelm. I haven't met in person most of you, including Mark. So I thought this video might, in addition to showing an idea that I have, might also give you the opportunity to at least see my face, even though I don't see yours. But first I have to apologize for having to miss the conference call on Tuesday. I'm in Washington, D.C., and Tuesday was a little crazy because we had this storm coming in, so people were literally evacuating offices, and I had to, I had to leave early. I couldn't get my time right, and I certainly missed the meeting. But I was left thinking, and I was looking forward to having that meeting because, one of the things that was commented before the meeting was that we needed to come up with something a little bit, I don't remember the right word, but sexier or more attractive for the research, and that got me thinking a little bit about something that I've been working on, and I wanted to show today a little glimpse as to what that might be, and it's essentially tying the results of all these models that we're going to be doing and the observations we're going to be collecting that are going to be integrated, tying that into some form of impacts and decision making, and maybe a policy-oriented variables. So essentially, it's translating or complementing the suite of experimental and modeling tools that we have with a set of decision making assessment tools. And I wanted to show you a little bit of a mock-up. It's not, it's by no means something that has no real data in it, but it's just a proof of concept, just to show you what it looks like. And hopefully this will help us, move forward, and maybe we can incorporate a something like this into our work. So I'm going to show you a very brief video of what I've been working on, and hopefully you like it, and maybe we can discuss this next time we have a conference. Okay, nice seeing you. Okay, so what I'm showing here is it's what's referred to as a system dynamics model, and this is a very rough formulation. Like I said, it's got no real data. It's got actually no real structure, but the way I did this mock-up version is that I have three types of variables. In the boxes I have what I call ecosystem services in black, and I've defined 4 ecosystem services that will be provided by these mangrove ecosystems that we're going to study. The first one is storm surge protection. The second one is fresh water for human consumption. The third one is flow for hydropower. Imagine that there's some hydropower nearby, and the next one is an agricultural service that I call the size of the quality crop. Okay, now these services are essentially calculated or conceptualized based on variable outputs that come from our data in experimental setup, and those variables are in blue. I'm calling those mangrove density. Okay, so this is the density of the mangroves in the system, the depth of water depth, the salinity of water, and the net water flux. Okay, so what I'm assuming is that we should be able, from our experimental modeling setup, we should be able to, for a given site, provide an estimate of mangrove density, water depth, water salinity, and water net flux. And those will somehow translate quantifiably into these 4 ecosystem services that we've defined. Okay, now these 4 ecosystem services in turn generate 4 types of decisions or activate some decisions. So, storm surge protection activates emergency management measures. Okay, and those are in red. So these are decisions or policies or actions that essentially translate our results from the experimental and modeling setup into something that's actionable. So emergency management is one. Fresh water for human consumption as a service would activate a decision. For example, water supply operations. Depending on how much water you have available, you might decide to operate a water treatment plant or a water supply system differently. Okay. The flow for hydropower ecosystem services activates a decision or policy that I'm calling allocation to electrical grid. Okay. And then last but not least, the ecosystem service that I call size of the quality crop activates or results in a policy or a decision that I'm calling market price of crop. And imagine that, if salinity goes up and water depth goes down, there's you can harvest less crop, and then of course the market price would go up. That type of impact. Okay. Now the way this model is set up, it's in a very dynamic form. The blue again would be things that we would generate from our models, and those might be time series or spatial distributions. And I just want to show you how this works very quickly. I want to keep this video very short. But essentially, if I lock the screen here, and I have what I have here on the right are 4 graphs that are essentially the quantities for the 4 ecosystems services provided. Water for human consumption is expressed here in meters per day. This might be difficult for you to read. Storm surge protection is a percentage. It's a dimensionless number as I'm defining it. Again, these are not real numbers. I just want to show you general structure. The size of the quality crop is in kilograms per square meter. The flow for hydropower is also in meters per day. Now, one thing that's nice about adding a tool like this is I'm going to do something that's called a interactive simulation, and I can I can click here, and what's going to happen is that, let's see, what's going to happen, oops, got to do something here very quickly, say yes. So now I get these knobs that I can turn for the 4 variables that I'm extracting out of the modeling experimental piece. So for example, if I tweak the mangrove density up or down based on model results, you're going to see that the graphs on the right start to change. You can see that at least one graph, the storm surge protection graph, changes. And so this is essentially, it triggers a decision or a policy based on an impact that it'll have. If I take the water depth and I tweak it, then I got all these variables changing. See, and you can actually think about each of these graphs being in some sort of decision-making format. Maybe something that I'm experimenting with now. It's what I'm calling a water decision theater, and it's essentially, it's water-based, but it's the same concept. Each of these graphs would go on a large screen in a place that is populated by decision makers or by stakeholders, and then you can see the impacts of a change in the system in real time. If I change the water salinity, for example, again, you start seeing changes in the availability of water for human consumption and also in the size of the quality crop. If I change the net water flux, then pretty much all the variables change. Actually, not the storm surge protection, but that's just because of the way I structured the model. So essentially, I thought about doing something like this as a way to add on a more end user tool, something that is more centered on the impacts on policies and also on the stakeholders, so that we could tie the experimental, the modeling, the remote sensing, and all these nice tools for each of the sites that we could do something like this. I mean, not all the sites are going to have the same ecosystem services. Some sites will have other ecosystem services that I don't have here. And I'm going to stop the simulation here. But I thought something like this could be useful to do, and we can certainly prepare a prototype like this at the proposal stage if it's desired. But I wanted to share this with you. That was pretty much it. I hope you enjoy it, and maybe we can get to discuss it next time. I will email you a link to this video, and we can talk about it. You can email me also if you have any questions. Okay. So I'm gonna say goodbye now and wish you well.